All right, so this is lesson 1.06, solving linear inequalities. For the sake of time, again, I'm going to skip over some of these, and you can always go back and view the lesson on your own time. So solving linear inequalities, skill check, make sure that you know how to graph solutions to inequalities in one variable, interval notation, set notation, absolute value, and graphing absolute value functions in two variables. So we have our inequality. Remember that A less than B, less than or equal to, greater than, and greater than or equal to. And then the slash through the equals is does not equal. Set notation is like this. So we have the little curly bracket, and this says the set of x such that, that's that little bar, that x is greater than 5. So we have a little bit of a difference between set notation and interval notation. Interval notation from an inequality can be written as, so -2 less than or equal to x less than 0 can be written as square bracket -2, comma 0 parentheses. Okay. Compound inequality in one variable. So the intersection means and then the union means or. And so an example of and, x is greater than -3 and less than or equal to 2. And what that looks like as your inequality is written like this, set notation and then interval notation, and then graphing that on a number line. We have 2 included, -3 is not included, and then the line is between because of the word and. So and means it includes everything between. An example of or would be x is less than -3 or x is greater than 2. In set notation, the set of x of all x such that x is less than -3 or x is greater than or equal to 2. What that looks like in interval notation is we have parentheses -infinity to -3, union 2 to positive infinity, and then just make sure you understand where those parentheses and brackets go. And then on a number line, that looks like negative infinity up to -3, not including, or including 2 up to positive infinity. Absolute value, if the absolute value of u is less than or equal to a, then you can rewrite our inequality as -a less than or equal to u less than or equal to a. If your inequality is set up so that the absolute value of u is greater than or equal to a, then you have an or statement. So u is less than or equal to -a, or u is greater than or equal to a. Notice that this stayed the same. The symbol and the sign on A stayed the same as the original inequality. The opposite of that, so the addition to this one, is you change the sign and change the sign, the inequality symbol, and change the sign on the constant or the other side. So let's move on to solving a linear inequality. Make sure that you go back and take notes on all these things. I'm going to skip through some of these and jump down to the guided example 1. So find the solutions to the linear inequality, graph the solution on a number line on your own paper. And so step 1, we are going to distribute. So 3 times x is 3x. 3 times -2 is -6. Combine our like terms, so 4 and -6 make -2. Make sure you bring that 3x down. And then we're going to add 2 to both sides. So 19 plus 2 is 21. And then to solve for x, we divide both sides by 3. So in this case, x has to be greater than 7. 21 divided by 3 is 7. And so in set notation, the set of all x such that x is greater than 7. In interval notation, since we know that x is greater than 7, 7 is our lower value. And so then that goes off to positive infinity. And make sure for infinity you type in INF. And then whenever you have infinity, it is always a parentheses. Moving on to solving a compound inequality. So, let it load. Whenever we have an and, that is equivalent to breaking it into these two pieces. Or compound inequalities, it is already in those two pieces. And then we write a union in interval notation instead of the word or. There is a video for the or and the and. If after this lesson video you still need some additional assistance, make sure you go back and kind of just check those out. A couple more examples there. So we are going to start with guided example 1. Select the solutions to the compound linear inequality. Graph the solutions on a number line on your own paper. So there's already an or between it. It is just two inequalities. And so we are going to just simplify both. So start with the first one. So the 4 plus 7x less than 5x minus 2. I'm going to start always by moving this x term to the left, because notice that all of your answer options have the x on the left side of the inequality. So subtract 5x from both sides. 7 minus 5x leaves me with 2. And I'm left with negative 2 on this right-hand side. Subtract 4 from both sides. And negative 2 minus 4 is negative 6. And then divide both sides by 2. And negative 6 divided by 2 is negative 3. So that already tells me that my answer options are going to either be this one or this one down here. So B or D. And then we take and solve the other side of this. So 4 minus 5x less than 6 minus 4x. Again, I'm going to start by moving the x term that is on the right-hand side of my inequality. So take and add 4x to both sides. Negative 5 plus 4 is negative 1x. Subtract the 4 over. So 6 minus 4 is 2. And then last but not least, we have to divide by this negative 1. So whenever you divide by a negative, we flip the sign, and then 2 divided by negative 1 is negative 2. And so that gives me this option here. Okay. Written in interval notation. This out the way. We have x is less than negative 3. So in interval notation, we are going to start from negative infinity up to negative 3, and it's less than, so that is a parenthesis. Or we're going to write as the union, so capital U. And then it goes x is greater than negative 2, so negative 2 to positive infinity. And so that is all parentheses on that interval notation. For guided example 2, we have a compound inequality. I'm going to try to do this all in one line, which we are just going to split into the two pieces. So 5x plus 3, I don't think I have. We're just going to use this symbol for now. 3 plus 6x. And then the other side of this is going to be the 3 plus 6x less than 5x plus 10. Since I do not have the less than or equal to, we will just have to remember that when we get to the bottom. And we're going to solve both of these. So for this one, again, I'm going to always start by moving that x that's on the right-hand side over here. So by subtracting 6x from both sides, I have negative x plus 3 less than or equal to 3. On this one, subtract the 5x to this side, and I have 3 plus 6x minus 5x is 1x less than 10. To finish solving this one, well, not finish, but next step is negative x. We would subtract the 3 to the right-hand side, so this is less than or equal to 0. And then same thing here, subtract the 3 to the right-hand side, and 10 minus 3 is 7. Final step, since this is a -1, we are going to divide by -1, so we flip the sign. Again, this is greater than or equal to 0, and this is x stays the same, less than 7. So we know that x is greater than or equal to 0, but less than 7. So we can rewrite this as 0 less than or equal to, again, I don't have that symbol, so just remember that it's less than or equal to x less than 7. And so it's this one here. And then written in interval notation. So since x is between 0 and 7, 0 is included. We have a square bracket, 0, 7, and then parentheses, 7 is not included in that interval notation. Moving on to solving an absolute value inequality. Again, read through those, greater than, less than. If you know your rules, great. I'm going to jump to this guided example 1. Let me see if I can set this up correctly. There's lots of spaces here. All right, so since this is less than, I am going to first start by just rewriting what I have without the absolute value. And then my second one is going to be flip the symbol, flip the inequality symbol, and change the sign on the constant. Okay. And now we solve both of these inequalities. So starting on this one, I would take and add the 9 to both sides. So I have -6v less than or equal to 27 plus 9 is 36. On this one, I would do the same thing. So I would still add 9. So I'm going to bring down this -6v. However, -27 plus 9 is -18. Divide both sides by the -6. So remember that you do have to flip the sign. So again, this is greater than or equal to, I just don't have the symbol. So v is greater than or equal to 36 divided by -6 is -6. And then same thing here, divide by the -6. Since we are dividing by a negative, we're going to flip the symbol, and -18 divided by -6 is a +3. So we have that v, or in our answer choices, x, is greater than -6, but also less than 3. So we can rewrite that as -6 less than x less than 3. But these are less than or equal to. I just don't have the symbol, so that is that one there. So remember to split it, rewrite the absolute value inequality as you see it, and then separate. This is because it's a less than. Separate, flip the sign, change the sign on the constant, or the value that's not in the absolute value. All right, and then writing this in interval notation, we have -6 included, 2a positive 3 included. Guided example 2. So select the solutions to the linear absolute value inequality. I'll get there. And so we are going to write this as 2x plus 7 greater than 9, and 2x plus 7 less than -9. Subtract 7 from both sides. 9 minus 7 is 2. And -9 minus 7 is -16. 2 divided by 2 is 1. -16 divided by 2 is -8. So x is greater than 1 or less than -8. We can also just rewrite that as x is less than -8 or it is greater than 1. And then in interval notation, so since we have that or, remember it is a union, so x is less than -8, meaning that it goes to -infinity up to -8. It is not included, so we use a parentheses. It is greater than 1, so 1 to positive infinity. Moving on to real world applications. Again, video, lots of examples, should you need more. Joe needs to book at least 50 total rooms for a company work trip. Joe has already reserved and paid for 16 rooms, so he needs to reserve additional rooms. He can only reserve rooms in blocks B. Each block contains 8 rooms. So at least 50 means that 50 has to be that minimum. So more than or equal to 50, greater than or equal to 50. The inequality that represents this scenario is 16 plus 8b greater than or equal to 50. Find the solution to the inequality. So we would start by subtracting 16. Let me get my calculator up here. And I'm just going to use x. Well, I'll use b. I don't think it'll change anything. 16 plus 8b greater than or equal to 50. Start by subtracting 16 from both sides. And we're left with 8b greater than or equal to 34. And then divide both sides by 8. 34 divided by 8 is 4.25. Since he cannot reserve partial blocks, he will need to reserve 5 additional blocks. Each block costs $900. So 5 times 900 is 4,500. Make sure that you include that comma. So he'll need to spend $4,500 on additional rooms. A gym trainer wants a client to burn 32 calories during a short workout. The client burns calories in sets S, where each set burns 4 calories. I don't know why this is an L here. should be an S, but that's okay. And so if a trainer is okay with the client, the trainer is okay if the client is within 8 calories above or below. So that 8 is going to be this number here. And since we are looking at this final sentence here, the difference between the calories burned and the target must be no more than 8 calories. We're looking for 8 below, 8 above, so that is going to give us an and situation. And so we can rewrite our absolute value inequality as such. So -8 will be the low end, +8 will be the top end, and then our inequality in the middle. Again, it does say 4L, but we are actually using 4S, minus 32. Oops, let me submit these as we go. And so we're going to add 32 to both sides. So -8 plus 32 gives us 24, and then divide by 4 gives us 6. Add 32 to 8 over here gives us 40, divided by 4 is 10. Interval notation, remember these are included because it's less than or equal to, so 6, 10, close brackets. And the client should complete between 6 to 10 sets to be within that calorie range. Okay, and that's it.